Hello, and welcome to this T-Level Tactics video on database structures for Root Core 3 data of the T-Level Digital Support Services course. And in this video, we're going to identify what database structures are, we'll compare some different database structures, and we'll also analyze the impact of database structures on operations. Before we get started, these videos are not endorsed or sponsored by any education institution or qualification awarding body. And T-Level Tactics videos should not be used as a replacement to any classroom learning you might be receiving, as the discussion and practical activities with your peers and lecturer will help to expand your thinking and comprehension. Instead, these materials are best used as preparation material or as revision to reinforce your learning. And these videos cover the same content and required knowledge for Root Core 3 of the T-Level Digital Business Services course. However, they will be more contextualized towards IT support roles. Let's find out what database structures are. Not all databases function the same, and not all databases are suitable for all use cases. Depending on what you're doing and how complex your data is, you may wish to choose a specific type of database structure. The database structure dictates how raw data is stored, and it's similar to the data models that we looked at in video 5. But whereas that was more of a logical representation of how data is displayed, database structures dictate where exactly the data is located and organized. They enable easy processing, interpretation, and utilization by different software applications. Different database structures will store data in different ways. They can store different types of data, or some won't be able to store some types at all. Remember those different data types? Numeric, text, dates, files, things like that. And different structures will encode data differently for storage and transmission, and will also have different ways of validating data for quality and integrity. So why are they important? Well, choosing the right structure for your database will facilitate data management and retrieval, ensure data integrity and consistency, support interoperability between different systems and applications, and influence the efficiency of data analysis and reporting. So let's look at some different database structures. There are 3 different database structures we're going to take a look at: file-based, directory-based, and relational. In file-based structures, data is stored in a single file, a flat file such as a CSV, TSV, or another text file. All contextual information about the data is held in that file, such as the table headings. And basic validation rules can be applied. They're commonly used for simple data storage and retrieval. Now, file-based databases are somewhat simple. The files are easy to create, read, and write. There's some portability here where they can be easily shared and transferred between different software and different systems. They're usually cross-platform compatible between Windows, Mac, and Linux. And they have low overhead, meaning they're not that resource intensive. You can use quite a low-powered server or system to power file-based databases. They're ideal for small datasets. But there are some scalability issues. They're not that suitable for large datasets or complex queries to be run. And in terms of data redundancy, there is the potential for duplicate data entries and inconsistencies. They're also limited to no relationships between different datasets and files. In a directory-based database structure, data is stored across multiple files organized in a directory. It allows for more complex data organization. The context of the data is held both in the file and in the directory structure. And any relationships are referenced within these files. Data can be organized in folders and subfolders, creating a hierarchy like we may have seen before. and can support multiple data contributors and owners. We're most likely to find this in content management systems for documents, images, media, things like that, or in data warehouses that organize data from multiple sources. Directory-based structures often resemble a tree, with the database as the starting point. This will branch out to the different tables, with each then branching out to individual records. Each record stores its own attributes. In this example, each customer gets their own subdirectory that contains a file with all their details in. Each customer can have multiple orders, and each order within an order directory references their customer ID and product IDs within. With directory-based structures, you get a lot better organization. It facilitates the management of large, complex datasets. And there's some flexibility there. It allows for a diverse range of data types from multiple different sources. In terms of scalability, they're a lot more scalable than file-based structures for growth. But they can get quite complex. They're a lot more complex to manage and retrieve data from, as there's going to be lots and lots of directories created that you'll have to navigate through. And in terms of data inconsistency, there is the potential for quite a lot of these if it's not managed correctly. There's also a lot more overhead involved, requiring more resources for storage and management of data. Relational database structures store data in structured tables, and it uses relationships to connect data across these different tables. They'll often have a single database file that contains the details of all of these relationships between the different data, and can store all of that data within that same database file as well, such as a Microsoft Access database. In a relational structured database, data is stored in rows and columns in tables, and the data is normalized. Normalization aims to simplify the presentation and storage of data, eliminating redundant data to save space, and trying to ensure data integrity. Normalization can simplify updating, adding, and deleting data without affecting other data in the system. There's more on normalization in a future video. Data and tables are all linked through primary and foreign keys. We can also use SQL for data manipulation and querying. Relational structured databases do have quite a lot of advantages. In terms of data integrity, we can enforce data accuracy and consistency through different constraints. We can also handle some very complex queries. We can retrieve data using queries using SQL. In terms of scalability, we can handle massive volumes of data and multiple users at the same time. And in data security, we can have some robust security features in place to protect sensitive data in our database. However, again, they can be quite complex. They require some really careful design and management of schemas and relationships. And entity relationship diagrams are essential for effective planning and management. In terms of performance, there is the possibility for performance issues, especially with very large datasets or complex joins and relationships. And the cost involved, they can be quite high as well, especially where you need to license software for enterprise solutions that's proprietary from different manufacturers. So that's a quick look at some different database structures. So if you're a Patreon member, head over to patreon.com/tleveltactics and download the task sheet for this video. Have a go at completing the first task. It's not going to take very long, only about 20 minutes. There's also only 2 tasks for this video, as opposed to 3 like we usually have. If you're not a member yet, head over to patreon.com/tleveltactics to take a look at all the exclusive content that our T-level tacticians get access to. If you want to, sign up, download the task sheet, and you can join in with us. Pause the video here, have a go, and then come back when you're ready to move on to part 3. let's have a look at how these different structures can affect the operation of our database. Choosing the right structure for your database can impact the operational efficiency of your system. Every second longer it takes to add data or run a query is time that will cost the business. So the most effective solution will also likely be the cheapest in the long run. Well-structured databases and data formats allow for efficient querying and enable the use of powerful query languages like SQL for complex data retrieval. So for example, relational databases allow for join operations to combine data from multiple tables together. And consistent data formats facilitate easier updates and modifications. It reduces the risk of data inconsistency and redundancy. As an example, normalized databases allow for changes in one place without affecting other records. Structured data formats enable effective data analysis and reporting, and facilitate the application of analytical tools and techniques such as data mining and statistical analysis. Well-organized datasets will allow for easier identification of trends and patterns, for example. You also need to think about sharing of data with different systems and different people. Standardized data formats promote interoperability between systems and applications, enabling seamless data sharing among stakeholders, departments, and organizations. For instance, formats like CSV and JSON are widely used for data exchange. So database structures play a crucial role in data analysis by enhancing query efficiency, maintenance, analytical capabilities, and data sharing. And understanding the importance of database structures is essential for effective data management and decision making. Picking the right structure will have lasting benefits or consequences in the future of your database. So for Patreon members, it's time to have a go at task 2 back on the task sheet. This one is a fairly in-depth task. I think it will take you about 60 minutes. But remember, there's only 2 tasks for this video, so it is the final task. Pause the video here, have a go at that task, and then come back and we'll finish things off with some exam questions. So in this video, we've identified what database structures are, we've compared different database structures, and we've also analysed the impact of database structures on the operation of your database as well. So let's have a go at some exam-style questions. Here's the first. Explain the elements of a file-based structure. And the second, compare and contrast file-based and directory-based structures. That brings us to the end of the video. In the next video, we'll be taking a look at something called ACID and also a deeper look at normalization that we've mentioned a couple times already. So make sure you're subscribed at youtube.com/@tleveltactics. And if you haven't taken a look at the Patreon yet, head over to patreon.com/tleveltactics to see all of the exclusive content that our T-Level tacticians get access to, like our Spotify exclusive podcast editions. Thanks for watching and see you next time.